Right now, somewhere in your arm, there's a battle happening that you can't feel, can't see, and probably don't think about once the Band-Aid comes off. A vaccine just walked into your body, carrying what looks to your immune system like an invading enemy. And your body is scrambling to fight it off, learning everything it can, and then filing that information away for years, sometimes decades, just in case the real enemy ever shows up. So how does a tiny shot in your arm teach your entire body to recognize and destroy a threat it's never actually seen before? That's what we're going to walk through today, step by step, from the moment the needle goes in to the moment your immune system stands guard for good. Let's start with what you actually experience. You go in for a shot. Maybe your arm's a little sore the next day. Maybe you feel a bit tired or run a low fever. And then, nothing. Life goes on. It feels almost anticlimactic for something that's supposedly protecting you from a disease. But that soreness and fatigue aren't side effects in the sense of your body malfunctioning. They're actually a sign that something important is working exactly as intended. That mild discomfort is the visible tip of an enormous, invisible operation happening inside you. To understand that operation, you need to understand what your immune system actually is. It's not one organ, and it's not one mechanism. It's more like a security network spread throughout your entire body, made up of different specialized cells that each have a specific job, all coordinating with each other like departments in a massive, decentralized agency. And the reason vaccines work at all comes down to one core idea. Your immune system doesn't fight diseases it recognizes. It fights diseases it's learned to recognize. The first time your body ever encounters a truly new virus or bacteria, it's flying blind. It has no idea what this thing is, what it does, or how to stop it fast enough. That confusion and delay is exactly why first-time infections can be so dangerous. Your body eventually figures out a defense, but by the time it does, the invader may have already done serious damage. A vaccine's entire purpose is to skip that dangerous learning period, safely, before you're ever exposed to the real thing. So how does it actually do that? Let's follow the journey. The moment the vaccine enters your arm, it typically stays in the muscle tissue where it was injected, at least initially. And waiting right there, patrolling that tissue like beat cops on a nightly route, are cells called dendritic cells. Their entire job is to detect anything that looks foreign and grab a sample of it. Now, here's the clever part. And it's the part that varies depending on the type of vaccine. Some vaccines contain a small, harmless piece of the virus, like a protein from its outer shell. Others contain a weakened version of the whole virus that can't cause disease. And newer vaccines, like the mRNA vaccines that became widely known during the COVID-19 pandemic, contain genetic instructions that tell your own cells how to temporarily build one harmless piece of the virus themselves. But regardless of which method is used, the goal is identical. Get your immune system to see a piece of the enemy's uniform without ever exposing you to the actual enemy. Once the dendritic cell picks up that viral piece, called an antigen, it doesn't just sit there. It physically travels, moving through your lymphatic system, which is basically a separate circulatory network running alongside your bloodstream, to a nearby lymph node. Lymph nodes are the reason your neck sometimes feels swollen and tender when you're sick. They're small, bean-shaped structures scattered throughout your body, and they function like regional briefing centers for your immune system. This is where the real recruitment happens. Inside the lymph node, the dendritic cell presents that viral fragment to other immune cells called T cells and B cells. Think of T cells as your immune system's specialized soldiers and coordinators, and B cells as the factories that manufacture weapons. Here's where it gets genuinely fascinating. Your body doesn't have T cells and B cells that are pre-made for every possible virus on Earth. Instead, It has an almost unimaginably vast and diverse pool of cells, each one slightly different, each one capable of recognizing a slightly different shape. When the dendritic cell shows up with its sample, it's essentially running a lineup, searching through millions of candidates until it finds the small number of B cells and T cells that happen to match this specific invader. When a match is found, that specific B cell gets activated and starts rapidly cloning itself. And this is where the B cells transform into what are called plasma cells, tiny biological factories that pump out antibodies. Antibodies are Y-shaped proteins built specifically to latch on to that exact viral protein, like a custom-made key that fits one very particular lock. Once attached, antibodies can neutralize the virus directly or flag it for destruction by other immune cells. At the same time, activated T cells take on different roles. Some become helper T cells, which coordinate the whole response and boost antibody production. Others become killer T cells, which can directly destroy any of your own cells that have already been infected. This entire process, from injection to a fully mounted immune response, typically takes days to a couple of weeks. That's part of why you're not considered fully protected immediately after a vaccine. Your body genuinely needs that time to build up the antibody supply and fine-tune the response. But here's the part that actually explains why vaccines work long-term, and it's the part most people never think about. After the threat is dealt with, or in this case, after the vaccine's antigen is cleared from your system, most of those specialized B cells and T cells die off. Their job is done. But not all of them. A small subset transforms into what are called memory cells. And memory cells are essentially veterans who stick around. They don't actively patrol like the frontline soldiers. Instead, they sit quietly in your lymph nodes, bone marrow, and bloodstream, sometimes for years, sometimes for the rest of your life, holding on to the exact blueprint needed to fight that specific invader. This is the entire point of vaccination. You're not just triggering an immune response, you're training a specific team and then keeping them on permanent retainer. So what happens if you're ever actually exposed to the real virus later on? This is where the payoff becomes obvious. Instead of your immune system starting from zero, confused and searching through millions of cells to find a match, those memory cells recognize the invader almost instantly. They multiply rapidly. Antibody production ramps up within hours instead of weeks, and in most cases, the virus gets neutralized before it can multiply enough to make you seriously sick, or in some cases, before you notice any symptoms at all. That's the real mechanism behind vaccine protection. It's not a force field, it's a head start. Now, it's worth addressing something people commonly misunderstand. A sore arm or mild fever after a shot doesn't mean the vaccine is making you sick, and it isn't a sign of the immune response failing. It's actually a visible byproduct of your immune system reacting locally, sending in blood flow and immune cells to the injection site. Different vaccines and different individual immune systems produce different levels of these temporary symptoms, which is why some people feel almost nothing, and others feel noticeably run down for a day. It's also worth clarifying why some vaccines require multiple doses spread out over weeks or months. That first dose primes the system, essentially introducing the antigen for the first time and generating that initial, smaller wave of memory cells. The second dose, sometimes called a booster, hits that already primed system again, and the response is faster and considerably stronger, producing more memory cells and often longer-lasting protection. It's less like teaching something from scratch twice and more like reinforcing a lesson until it truly sticks. And why does immunity fade for some diseases but not others? This varies significantly depending on the specific virus or bacteria, how quickly it mutates, and how long memory cells for that particular pathogen tend to survive in the body. Some vaccines provide protection that lasts for decades or possibly a lifetime. Others fade over time or need updating because the virus itself changes, which is part of why flu vaccines are reformulated on a yearly basis to match the currently circulating strains. So, from your perspective, a vaccine seems almost impossibly simple. A quick injection, maybe a sore arm, and that's it. But behind the scenes, you've just triggered an intricate biological search and training operation. Dendritic cells collecting evidence, lymph nodes running identification, B cells building custom weapons, T cells coordinating the assault, and a select group of veteran cells standing guard in your body for years afterward, quietly waiting. It's not magic, and it's not a shortcut. It's your own immune system, given a preview of the exam before test day. So the next time you get a shot and think, "That's it, that's oddly simple," now you know what's actually happening underneath your skin. Your body just met an enemy it will likely never have to struggle against for the first time again. And that makes sense. If you enjoyed pulling back the curtain on something this small and this powerful, consider subscribing to That Makes Sense. We break down the hidden systems behind everyday life, one curious question at a time.